when you do a chemical reaction, you take reactants, combine them together, do something with them, maybe heat them or whatever, and you end up getting products. You can work out, as you know from the reactive mass calculations we've done, how much of the product you're expecting to get. But in reality, you don't always get exactly what you are expecting to get. The mass of the product you get is called the yield. Let's say in this experiment I get 1 gram of iron produced. That would be what we call the yield. But we have to be able to work out something called the percentage yield. And this is nearly always less than 100%. That's because some of the product hasn't been made. And there's a number of possible reasons for that. And we're going to start off by thinking about what those reasons are. Then I'll show you how to do the calculation. So one of the main reasons, I think there's sort of a couple of main reasons you can turn to in your exam. One of the main reasons we don't get the entire amount of, or we didn't get 100% yield, is because the reaction might not have gone to completion. It might be in this reaction we've taken iron oxide, heated it with carbon monoxide, and maybe some of the iron oxide never came into contact with the with the carbon monoxide, so the reaction didn't go to completion. Another situation where you might not get reaction going to completion is if the reaction is in an equilibrium. We'll talk about that later in the course, but reactions sometimes go forwards and backwards. We've got what are called reversible reactions. And so the reaction might not have gone to completion for that reason as well. Another reason the reaction might not be 100% yield is because there's sometimes other reactions taking place that we don't want. And this is not an obvious concept for year 11, because up to this point we've just assumed that everything does what we're expecting it to do. But in reality, lots of side reactions can go ahead. One example of a side reaction you are familiar with is incomplete combustion. We might, when we burn methane, for example, want to get and expect to get carbon dioxide and water, but instead we might also get carbon monoxide and soot produced as well. They are side reactions that might reduce the percentage yield. There are some other possible causes of lower than 100% yield as well, which could be that during the purification, so separation methods like filtration, for example, or transfer errors when you're transferring something from one flask to another. But the first two reasons I gave, incomplete reaction and side reaction, are enough to get you all the marks. Let's go through how you work out percentage yield. But essentially, it is the mass of the product you actually make divided by what you're expecting to make times by 100. It's a very simple percentage calculation. Let's just work through one example with you in this video. So this reaction, you're told that you've got 126 grams of iron oxide, that stuff. We've been asked to work out how much iron there is. So we'll go through the reacting mass calculation skill that we've spent a fair bit of time on. So write out the equation. Write down the molar ratio, which is 1 to 3 to 2 to 3. Write down the information you know from the question. Please write, if you're writing mass, please write it in grams and show the examiner you're writing it in grams. And we're told we've got 126 grams of iron oxide, so we're going to line that up with the iron oxide. 126 grams there. And we can then work out the moles by dividing by the formula mass. The formula mass of iron oxide is 56 out of 56 and 3 lots of 16, which is 160. So we can work out the number of moles by doing 126 divided by 60. Moles equals mass over mR, remember, and that comes to 0.7875. We've been told to work out the moles and the mass of iron, so it's a 1 to 2 ratio, so we times that by 2 and we get 1.575 moles of that stuff. The formula mass of the iron is 56. To get the mass, you do the moles times the formula mass. It gives you 88.2 grams. So that's our answer there, 88.2 grams. We're told in part 2 that we're expecting to get 78. We only actually got 78.5 grams. compared to our theoretical yield of 88.2. So to work out the percentage, is 78.5 divided by 88.2 times by 100 gives you 89.0%. Later on in that worksheet, there's a question, click on the other side. It says to you, give 3 potential reasons why the yield was less than 100%. This could apply to any of the questions. So you've either got incomplete reaction, which could come from the fact it's reversible or reaction just didn't complete, side reactions, or potentially the third one is some of the product lost during purification or transfer errors. That's it, folks.